Last week, one Spark job that used to finish in 12 minutes suddenly took 2 hours. No code change, same cluster, same dataset size. So what happened? We checked the storage path and we found 2,80,000 files, not gigabytes, files. And that's when we knew small files problem. Hello everyone, welcome to Big Data Factory. In the next few minutes, you will learn 3 things without confusion. 1. What the small files problem actually is. 2. Why it destroys Spark performance and increases cloud cost. And 3. Exactly how to fix it at the right time and after the fact using clean patterns. Small files problem means instead of storing data as fewer larger files, your dataset becomes thousands or millions of tiny files. In distributed systems, that's not harmless because a lot of engines, including Spark, pay overhead per file. So even if your data size is the same, the file count can make everything slower. Here are the top reasons you end up with small files in real projects. 1. Too many partitions while writing. People do repartition of 2000 without thinking. And 2. Partitioning by a high cardinality column, like user ID or device ID. Now each partition folder has tiny files. And 3. Streaming writes. Micro batches keep appending small chunks. And 4. Frequent incremental loads. Every hour or day appends a new set of small files. And 5. Over parallel ingestion tools. Many executors writing at once creates many output files. Why small files kill Spark performance? The real reason is Spark doesn't read a folder, Spark reads files. For many formats, Spark creates tasks based on file splits. So more files, more tasks. More tasks, more scheduling overhead, more metadata work, more open or close operations. And if you are on S3 or ADLS or GCS, listing and opening tons of objects is slow. So the bottleneck becomes not compute but file management overhead. Here is how you spot small files problem in 60 seconds. Spark UI shows crazy number of tasks for a simple read. Jobs spend time in scheduling, not processing. Stages have low CPU usage but long wall time. Listing the path itself feels slow. File sizes mostly like in KBs or few MBs. Fixing small files has 2 approaches. 1. Prevent it at right time, and 2. Repair it later using compaction. Now let's do both. So the first one, prevent small files at right time. The rule number 1, pick a target file size. For Parquet workloads, teams commonly aim for something like hundreds of MB per file, not 1 MB file. How do we do that? Here are clean patterns. The first one, using collays. If you currently have too many partitions, use collays to reduce partitions without full shuffle. And the second one is repartition. If you need balance across clusters, use repartition to full shuffle and for better distribution. And the number 3 is the limit records per file, like while writing, specify the number of partitions. And then the last one, using partition by. So partitioning is good, but partitioning by high cardinality key creates tiny files. Now compaction. Now if your lake is already messy, don't worry. You run compaction, rewrite many small files into fewer big files. The exact command depends on table format. If you are on Delta Lake, you use optimize to compact files. If you are on Iceberg, you use rewrite procedures to rewrite data files. If you are on Hoodie, use clustering or compaction depending on table type. Conceptually it's the same, read small files, rewrite fewer bigger files. Now we get into the streaming case. Streaming is where small files are burned. Because every micro batch writes its own chunk, so you need a strategy. 2 clean options. Periodic compaction job, like every hour or day, or write into fewer partitions, then compact. If you don't do this, the tables look fine in week 1 and becomes unusable in week 5. Quick mistakes to avoid. 1. Don't compact too aggressively during peak hours. 2. Don't choose crazy huge files if your queries are selective. Balance matters. And 3. Don't partition by high cardinality columns. And number 4. Don't run compaction without monitoring. measure before and after. So that's the small files problem. It's not a Spark bug, it's a data layout problem. And once you fix file size and do compaction, Spark suddenly feels 10x faster. And that's the end of this video. Please do like, comment, share and subscribe to my YouTube channel. And do let me know in the comment section what you feel about this video. We'll meet in next video. Till then, bye bye.